Hello and welcome to our talk in which I will describe the Humboldt contribution to the DrugProt shared task. My name is Leon Weber and this is joint work with Mario Sänger, Samuel Legada, Fabio Barth, Christoph Alt and Ulf Leser from Humboldt University in Berlin. So when we started out thinking about how we approach the relation extraction task of DrugProt, we thought about a general framework and we decided on relation classification because in our experience it's very robust. What relation classification means is that given a sentence and all its gold standard annotated entities, we select all valid entity pairs, so all chemical gene pairs in our case, and for each of those we construct one example. So because we have two chemicals and one protein here, we will construct two examples, one for each chemical. And then we mark up the chemicals and genes in this text and perform standard sentence classification with the pre-trained transformer. So now we thought about how can we improve on this general framework, and for that we thought about a lot of different modifications, and we tried many different combinations of them with the great Hydra configuration and sweeping framework, and so we evaluated over 2,000 different runs. And to give you a brief idea of what worked and what didn't, I have a list here. So green means it was better than the unmodified relation classification baseline, red means it was worse, and black means it didn't matter much. So what didn't work was to add additional and auxiliary data from different sources. To tune the thresholds for the different relation classes didn't work. To include relational knowledge base information in the form of text or knowledge base embeddings didn't work. And it didn't matter much what the representation of our text in the sentence classification is. What worked was to try different pre-trained transformers that had a lot of impact. Also random seed tuning improved results, optimizing the learning rate, the epochs, and the maximum length of the sentence had a lot of impact. And also what we found is that if we add textual entity descriptions for the chemicals, that worked, and also ensembling multiple models had a positive impact. So now that we had everything, or we had an idea of what worked, we took those ideas and we built our final model. So for our pre-trained transformers, we chose the Roberta Large model that was trained on PubMed and Mimic. We performed random seed tuning, we optimized the learning rate, epochs, and maximum length of the sentences, and we gathered textual entity descriptions from the CTT database. And to do that, we normalized the chemical names with the VII model, and we performed 10-fold ensembling by training 10 different models across different seeds and then averaging their predictions. Okay, so this is our final model, and everything so far was evaluated on the development set, but obviously we also wanted to test whether our modifications produce robust gains on the test set. So we submitted 5 different configurations, and now here we plot the improvement over the baseline run, in which we don't have chemical descriptions and we didn't ensemble, but which was already trained on the training and the development portions of the DrugProt set. So if we add then entity descriptions, that works a bit, but if we then ensemble our model by 10-fold, that improves results by much more. If we then do both, but only train on the training set, this improves results further. And if we then add the development portion to the training set, this leads to the best score, which is 79.73% F1. Okay, now we also wanted to know where in which classes our model performed well. So we checked the results per relation type, and we found that the results vary and that there's a modest correlation between the number of training examples and the performance, but this is certainly not the only explanation for this. So this needs further investigation. To conclude, we modeled the DrugProt task as a relation classification task with pre-trained transformers. We evaluated many different modifications in over 2,000 runs using the Hydra framework. We found that the adding textual chemical descriptions, ensembling, and training on train and development set led to improvements. And in our future work, we want to integrate the resulting model into our standalone relation extraction tool Pedal, and we want to investigate generative approaches for zero and few shot learning. Thank you very much for your attention. I'm looking forward to your questions now.